We can also find the volume of a solid with equilateral triangle cross sections using definite integrals. So if this curve is defined by f of x, then the length of this triangle is y. And because it's an equilateral triangle, all of the edges have the same length. And now we can find the area of this triangle using either trigonometry or Pythagoras' theorem. So half the base squared plus the height of the triangle squared is equal to the length of the hypotenuse squared. And then solving this for h, we get the height of the triangle. And then the area of the triangle is simply 1/2 by the base by the height. And then giving the triangle a thickness dx, the volume of one of those equilateral triangle cross sections is the area by the thickness. And then summing up the volumes of each of those triangular sections from x equals a to b gives us the volume of the solid. So in this case, the solid looks something like this. We can also find the volume of solids with isosceles right triangle sections. So these cross sections have two edges the same length with a right angle here. So considering this curve as y equals f of x, then the base has a length y, and therefore the height of this isosceles right triangle section can be obtained using Pythagoras' theorem. So therefore the height can be written as follows. And therefore the area of the section is half the base by the height. And then assigning a thickness to this section, and multiplying the infinitesimal thickness by the area of the section gives the volume of the section, and then we integrate from x equals a to b to obtain the volume of the solid. So the solid looks something like this. We will also find the volumes of solids formed by semicircular cross sections. So if we have a curve defined by y equals f of x, then the diameter of that semicircle is y. And therefore the area of a circle is pi by the diameter squared on 4, or pi by the radius squared. And we multiply by half to get the area of the semicircle. Now assigning the semicircular section an infinitesimal thickness dx, and multiplying the area by this thickness gives us the volume of that section. And integrating from x equals a to b will give us the volume of the solid. So the solid in this case looks something like this. Let's find the volume of a solid with equilateral triangle cross sections that are perpendicular to the horizontal axes. So the triangles lie in the YZ plane. And the base is bounded by the curve y equals x to the 1/2, the vertical line at x equals 4, and the horizontal axes. So the dimension of the triangle is described by y and each edge has equal length. And a triangle has equal angles of 60 degrees because it's an equilateral triangle. So therefore, to find the area of this triangle, we designate the height of this right angled triangle as h, and tan 60 degrees is root 3, which is the opposite on the adjacent edge. And therefore h is equal to root 3 on 2 y. And now to obtain the area of this triangle, we multiply 1/2 by the base, which is y, by the height, which is root 3 on 2y. And then we assign a thickness to this triangle, which is dx, and that gives the volume of one triangle, and we integrate from 0 to 4 to get the volume of the entire solid. And now you can simplify this and substitute x to the half, so that becomes x, and you'll be able to evaluate this integral. Let's find the volume of a solid with isosceles right triangle cross sections that are perpendicular to the horizontal axes or parallel to the YZ plane. And the base is bounded by the square root curve, the vertical line x equals 4, and the horizontal axes. So these edges are equal, and the hypotenuse is described by y. So therefore, by Pythagoras, we have a squared plus a squared equals y squared, and therefore a is equal to y on root 2. And therefore the area of the triangle is 1/2 by the base, by the height, and then we assign a thickness to the triangle, dx, which gives the volume of one triangle, and then we integrate from 0 to 4 to get the volume of the entire solid. And now you can substitute for y and evaluate the integral. And the solid volume looks something like this. Find the volume of a solid with semicircle cross sections perpendicular to the horizontal axes or parallel to the YZ plane, and where the base is bounded by the square root curve, the vertical line x equals 4, and the horizontal axes. Well, the diameter of the circle is described by y, and therefore the area of the circle is pi by the radius squared, and times 1/2 because we're looking at a semicircle. And we assign a semicircle a thickness, which is dx, and that gives the volume of one semicircle, and then we integrate from x equals 0 to 4 to get the volume of the entire solid. And you can substitute for y, evaluate the integral, and the volume of the solid looks something like this. Find the volume of a solid with semicircle cross sections that are perpendicular to the y-axis, and where the base is bounded by the square root curve, the vertical line x equals 4, and the horizontal axes. So the sections are going to be parallel to the xz plane as shown. And the square root curve can be described by x is equal to y squared, meaning that the diameter of the semicircle is going to be 4 minus y squared. And therefore pi by the radius squared, or the diameter squared on 4, gives the area of the circle, and multiplying by 1/2 gives the area of the semicircle. And then assigning a thickness to that semicircle, which is going to be dy, gives the volume of the semicircle section, and then we integrate from y equals 0 to y equals 2 according to this equation. And that gives the volume of the solid, which is going to look something like this. Let's find the volume of a solid with equilateral triangle cross sections that are perpendicular to the y-axis. So therefore they're parallel to the xz plane. And the base is bounded by the parabolic curve, the vertical line x equals 3, and the horizontal axis. So therefore, the edge of that equilateral triangle is 3 minus y to the 1/2 according to that equation, because we're going to integrate over y. And for the equilateral triangle, every edge has the same length, and every angle is 60 degrees. So tan 60 degrees is root 3, and that's equal to the opposite edge, which is h, on the adjacent, which is 3 minus y to the 1/2 on 2. Because we're looking at this right angle triangle. And therefore the height can be written as root 3 on 2 by 3 minus y to the 1/2, and then multiplying this height by the base, which is 3 minus y to the 1/2, and then multiplying this by 1/2 gives the area of that triangle. And we assign a thickness in the y direction, so that's dy, which gives the volume of the section, and then we integrate from y equals 0 to y equals 3 squared according to this equation, and that gives us the volume of the solid. Find the volume of a solid made up of a base that is a semicircle, and semicircle cross sections perpendicular to the horizontal axis. So these cross sections are all parallel to the YZ plane. And the diameter of each semicircle is described by this equation, and therefore the area of a circle is pi by the radius squared, and multiplied by 1/2 gives the area of the semicircle. And we assign a thickness dx in the horizontal direction to get the volume of one of those sections, and then integrate from x equals -1 to 1 to get the volume of the solid. And now you can substitute for y, evaluate that integral, and post your answer in the comments.